Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit current electricity. So let's begin with today's class. In today's class we are going to discuss about the power and energy. So let's begin with the energy and then we will come to the power. Initially we are going to discuss about the heating effect of electric current. This is also called as the Joule's heating effect because this relations and this observations has been given by the scientist named Joule. So what Joule is saying, he says that the heating effect is developing, that is developing, which is directly proportional to the square of the current that is flowing through it. It depends on the resistance of a coil or resistance of a conductor, and it depends on the time for which it is flowing. This depends on the I. I stands for current passing through the coil or conductor. R, it is the resistance of conductor, and T, time for which current is flowing. So if I relate this three relations or this three parameters in a one relation, I can write like this: H is equals to I square into R into T. That is the heating effect of electric current. We are coming back on this, but first let's discuss even this heating effect, that a different approach of same. It's an electric work done by any cell can be given as that work done is equals to potential difference divided by charge. We have defined potential like this only, that voltage is equals to work done by charge. So this voltage is equals to work done multiplied by charge. So W can be written as V into Q. Now what is Q? I know that I is equals to Q by T, and that Q can be replaced by I into T. So this is V into I into T. According to the Ohm's law, V is equals to IR. Let's just replace it over here. It's an IR multiplied by IT. It's an I multiplied by I, which is I square into R into T. This is one of the relation. W is equals to I square into R into T. One more term can be related as, if I replace this I with the help of V by R, if I replace I with the V by R, I can have W is equals to V square T by R. This is just the work done, and these work done can be stored in the body in a form of an energy. So what electrical energy? It is the work done by an electric current in a given time. So electric energy, that is equals to electric power multiplied by time. Work done can be written as P into delta T, or delta W can be written as IV into delta T. What is power? It's a P that is equals to delta W by delta T. If I replace this P with the VI, and or using Ohm's law, V is equals to IR, the power can be written as P is equals to I square R or V square by R. It is the power loss. Even we said this as an ohmic loss in a conductor R which is carrying a current I. I hope these things are clear. Is it? Yes. We even know that power is scalar or vector. Power, it's a scalar quantity or vector quantity. Yes, you are right. It's a scalar quantity. SI unit of power, what is it? SI unit of power, we can write it's a joule per second or watt. This is watt, not a volt, please. This is watt. Anything else? Joule per second and watt? Yes. One conventional unit, it's a horsepower, HP. This is horsepower, and the relation of horsepower with watt is 1 horsepower is equals to 746 watt. Yes, So please do remember these things. Please do remember these things. This are the very basics. These are the very basics of the electrical energy and power. Now let's take one by one cases of residential energy consumptions, and then we will move to the power. Now when we use an energy at residential, or let's say even the commercial purpose, we use a unit of energy. We use a unit of energy that is 1 kWh. This is kilowatt hour. We are using this unit and we call it as a 1 unit. It's a 1 kilowatt hour, that would be equals to 1 unit. And if I replace this 1 kilowatt hour, if I replace this 1 kilowatt hour into certain joule into second like thing, it's a kilo stands for 10 to the power 3 multiplied by watt, it is a joule per second, multiplied by hour, it's a 3600 seconds. Yes, 1 hour 60 minutes 60 seconds. Yes, so this can be written as 3600 multiplied by 10 to the power 3 joule, or I can write like this, it's a 3.6 into 10 to the power 6 joule. This is the equivalent of 1 kilowatt hour. So let's suppose the situation would be something like this, that let's suppose you have been given a certain component quantity, it's watt. Yes, let's suppose you are having a tube light at your home, let's say 10 quantity, and each would be of 40 watt, and number of hours it is going to be used, let's suppose that it is going to be used for 24 hours. So find out consumption. This is their question. So what I need to do is, it's a quantity, it's a 10, their watts, it's a 40, number of hours, it's a 25. So what I required watt multiplied by hour multiplied by kilo. So initially let's just find it out, watt into hour. This is 40 into 25, that is a 1000. Now I want a kilowatt hour, so divide it by 1000. So this is the consumption of 1 unit, but I have just multiplied this 40 into 25. So if I multiply with quantity 10, so 10 quantity will use 10 units of power, and each unit is consuming certain rupees, and that rupees will be given to you in a data, and you can easily calculate that what consumption does it take. I hope these things are clear. Is it clear? Is it? Let's look at one of the question like this. So what the data is given, according to the data, the particulars of electric items used in a house are listed below. What will be the electric bill of the house for 2 months? You need to consider each month of 30 days. If the rate of the power is rupees 2.70 per unit of electricity consumed. Okay, great. So what is given? Television set is given, refrigerator is given, tubes are given, bulbs are given, and one press is given. So what you need to do is, you need to just calculate watt into hour. So let's just calculate watt into hour over here. That is a television set, it's of single unit, and it is using 2 hours a day. 2 hours. Look at this. This is 2 hours a day. So this is 60 volts. So this is 60 into 2, which is a 120. Next, this is 60 watt and 24 hours a day. 24 6, it's a 144. So this is equals to 1440 watt into hour. 40 watt each, and 3 tube lights are there. So this is 43s are 120 and 124s are, this is 480 watt into hour. Next, bulbs are there, and 60 watt each, and total number of bulbs, two bulbs are there, that is the 60 into 2, it's a 120 watt multiplied by 2 hours a day. So this is 60 into 4, 60 into 4, it's a 240 watt into hour. And next, it's a press, it's a half hours a day, and one press is there, so this is 300 watt. So this is your total consumption, this is your total consumption. So if I add this, 0 0 0 0 0, this is 0, 2 plus 4 6, 6 plus 8 14, 14 plus 4 18, carry over 1, it's a 1 plus 1 2, 2 plus 4 6, 6 plus 4 10, 10 plus 2 12, 12 plus 3 15, carry over 1, 1 plus 1 2, this is 2580 units, this is 2580 units. So total consumption of each day is it is a 2580 units. If I convert this to, this is not a 2580 units, this is 2580 watt into hour, my mistake, look at this, this is watt into hour. So this is 2580 watt into hour, this is 2580 divided by 1000, which is 2.580 kilowatt hour, or we can say approximately, this is approximately 2.5 units. This is of each day, this is of each day. So total bill for 2 months can be calculated as that, this is 2.5 units for each day. For 2 months they have mentioned it is of 60 days, multiplied by per unit cost, this is rupees 2.70. So when you multiply this, you will get an answer, that would be the electricity bill of your consumption of this many devices. I hope this is clear. Is it clear? Is it? Any doubts in this? Anything? Is there anything? No? Great. Let's have one more question for practice purpose. Let's have it. Let's suppose you are having a quantity of 10 and item, it's a tube light, 5 fan, and let's say 2 air conditions, it's an air conditioners, power, tube light each of 40 watt, fan each of 50 watt, this all are in watts, and AC it's a 1200 watts. Number of hours that we use it, tube lights are used 12 hours, fans are used 12 hours, and ACs are used for 6 hours. And let's calculate if cost per unit is 5 rupees. Calculate bill for 30 days. This is required. So this is watt into hour. Let's have a calculate it. That 10 tube lights are there. Each would carry or each would be consuming a power of 40 watt, and they are going to be used. They are going to be used for the 12 hours. So this is 10 into 40, which is a 400. 400 into 12, it's a 4800 watt into hour. They are going to consuming it. Yes. Yes. Next, 5 fans are there, and they are going to be used for the 12 hours. So this is 50 into 12. I'm going to do this 50 into 12. It's a 600 into 5. This is 3000 unit. 3000 watt into hour, sorry. This is 1200 wattage multiplied by 6. It's a 12 into 6, 72, 72 into 2, it's a 14400. Now let's add it up. It's a 00, 8 plus 4 12, carry over 1, 1 plus 4 5, 5 plus 3 8, 8 plus 4 2, carry over 2. It's this much watt into hour is going to be used per day. So if I convert this to an kilowatt hour, it's a, this 2 has gone. So 1 unit or per day consumption, let's say we are consuming 22.2 units per day, because this is the usage of per day. Now what is the cost per unit? It's a 5 rupees. And for how much time I need to calculate this? I need to calculate this for 30 days. So total consumption and total bill for 30 days, it's an 22.2 units per day multiplied by 30 days multiplied by 5 rupees. So this is 222 divided by 10 multiplied by 30 into 5. So this has gone, and this is 222 multiplied by 15. This is the amount. This is the amount that is going to be used, or that would be the bill that has been generated. So can you do this kind of things? Can you? Is it possible by you guys? Are you sure? Great. Let's have a look at the next question. There are 5 tubelets. Now do one thing, have your pen, have your paper, do it with me. We are going to calculate the bill. Yes, do it fast. There are 5 tubelights and each of 40 watt. There are 5 tubelights, each of 40 watt in a house. These are used on an average for the 5 hours. It's a 5 hours. It's a quantity. This is power, and this is number of hours they are going to use it. In addition, there is an immersion heater of 1500 watt used on an average 1 hour per day. Okay. The number of units of electricity are consumed, that means it is of one quantity. The number of units of electricity are consumed in a month of 30 days. Great. So let's calculate watt into hour. There are 40 watt and total 5 quantities are there. So it's a total 200 watt multiplied by 5 hours. It's 1000 watt into hour. This is of 1500 watt. So this is total. It's a 00 plus 2500. This is of 2500 thousand and 1500. This is of 2500 watt into hour per day. This is the costing of, or this is the consumption of watt hour per day. So it's a 2500 watt into hour. Let's divide it by 1000. So it will give me a 2.5 kilowatt hour per day, or I can say it's a 2.5 units per day. We have a month of 30 days. We have a month of 30 days. So consumption of 30 days is 2.5 multiplied by 30. That is of 750 units of energy has been used. Yes, I hope these things are clear. Is it? Great. Let's look at the next question. Do it fast. Do it. What does it say? It says 10 50 volt bulbs. This is 10 or 50 volt bulbs are operated on an average for 10 hours a day. The energy consumed in kilowatt hour in 1 month of 30 days. This is the quantity. This is the power that has been used, and this is the number of hours. So first you are going to calculate this watt into hour. Whatever the watt into hour has been there, convert it to the kilowatt hour and multiply this with the 30 days. I hope now you must be able to do this. So please, this is try yourself. Yes, please do it, please. You need to do it, and this can be done. This is very easy. So let's move to the next question. What is saying? It's an energy in kilowatt hour that is consumed in operating 10 50-watt bulbs for 10 hours per day in a month of 30 days. Again, same thing. 10 bulbs are there. Each is consuming a 50 watt, and 10 hours they are going to be used. So if it's a 10 into 10, 100 into 5, this is 5000 watt into hour. Divided by 1000, it's a 5 kilowatt hour, which is 5 units. 30 days. 30 days. So it's a 5 units per day. So for 30 days, it is 150 units or 150 kilowatt hour. Both are the same thing. I hope this is clear. This is clear. Great. Next, what does it says? Next question, look at this. An electric heater of resistance 6 ohm is run for 10 minutes on a line of 120 volt. The energy liberated in this period of time is, yes, this is, we have been back with the Joule's heating effect. So what is given? Let's just find it out and let's summarize it. At electric heater of resistance R is given, it is of 6 ohm and it is running for the 10 minutes. So time is given, that is of 10 minutes, but I need to convert it. I need to convert it to a second because the units is the joule. It's a 10 into 60, that is 600 seconds on a line of 120 volt. The voltage is given, it's a 120 volt. So you need to find out the energy. How could you do this? We know that this H is equals to I square into R into T. Even I can replace the I with the V square by R square into R into T. So this could be written as V square by R into T. Now put up the value and get it done. It's a 120 whole square. Divide by resistance, it's a 6 ohm, and multiplied by time, it's a 600 of seconds. So this is 6 into 100. This is it. 120 into 120. This is of 144. Multiplied by 10 square, it's an 100 multiplied by 100. So this is of 144 multiplied by 10 to the power 4 joule. Find out the answer and get it done. Yes, it's a 14.4 into 10 to the power 5. I hope this is your answer too. Is it? Do you have a same answer? Do you? Great. Now again a question of energy consumption. A house is fitted with 10 lamps. It's in quantity, that's a 10, each of 60 watt, and each lamp burns for the 5 hours a day on an average. The cost of consumption in a month of 30 days at 2 rupees 80 paisa. Yes, for your help I have written it over here, but if possible please do not watch this, do not see this, and do it yourself. If you have been stuck anywhere, you can take a help from this solution, but I hope you don't require any help regarding this. Is it clear? Yes, so please do it yourself. This will boost up your confidence. Yes, the answer is 252. That has been ticked so that you can match your answer. I hope these things are clear and you are able to solve this kind of questions. Are you sure? Great. Now let's move to the second category of questions in the energy and power segment. That is the power and the voltage of the bulbs. That are the questions regarding with the bulbs. So how they are going to ask it, let's have a look. So before we go to that, this is the symbol of the bulb. This is the symbol of the bulb. And on a standard it is having a two ratings. One is the P, another is the V. The P rating gives the power of bulb, while V rating gives the voltage of bulb. Yes, so with this two we can find out resistance of the bulb. How could I? Let's have it. It's a P is equals to V square by R. So here if I solve this, it's an R is equals to V square by P. This is the resistance. This is the resistance of bulb. It is clear? This is the resistance of bulb. It is clear? Yes. Now one more thing I can have it's a P is equals to V into I. So I can be calculated as P divided by V. This is I, this is the maximum current that can safely pass to the bulb. This is the maximum current that can pass through the bulb safely. It even means that if this can be written as I max, if current is beyond the Imax, if current is beyond the Imax, this bulb will fuse. Is it clear? Is it clear that if current is beyond the Imax, this bulb will be fused? Is it clear? Yes. So only they need to provide a P and V, that a certain bulbs is there. It is consuming a power of 60 volt and it operates at 220 volt. They are going to just do this. From this data, from the power rating and from the voltage rating, we can have all this data, that what is the maximum voltage that can be applied to a bulb, what is the maximum current that can be passed through this bulb. If I'm going to send the power, or if I'm going to send the current that is beyond this, what happens? And everything can be calculated. I hope those things are clear. Is it great? So let's just try it questions on based on the power and voltage of a bulb. So let's suppose this two bulbs are there, and this is power P1 and voltage V. This is consuming a power of P2 and voltage of V, and they have been connected to a voltage supply that is of V. So this two P1 V and P2 V has been connected with the voltage supply of V. So what I assume and what I can understand is that, let's suppose the total power consumption of this circuit, total power consumption of this circuit is P, which can be written as P is equals to V square by R. Now as I understand that this two bulbs are connected in series, so can I write like this, that R equivalent, that should be is equals to R1 plus R2. And as I write R equivalent, I can write like this, it's a V square divided by P equivalent. This is equals to V square by P1 plus V square by P2. I hope these things are clear. So this V square has gone, and 1 by P equivalent can be written as 1 by P1 plus 1 by P2. Yes, this is the standard relation when bulbs are connected in series, or when any of the devices are connected in series, but they are having the same voltages, please remember this, they must be having the same voltages as the supply voltage. If this is not the case, you cannot use this relation. But if supply voltage is same, as the voltage rating of bulbs, you can definitely use this. This will help you. Such as, same way, let's derive the relation for the bulbs that are connected in parallel. So the situation must be something like this, and let's provide the power and voltage rating. This is P1V, this is P2V, and this is the V. Yes. So let's suppose, let us assume that total power consumed by supply is P. So I can understand that this can be written, which is of P is equals to V square by R, and from this I can write like this, it's R is equals to V square by P. So what I can have, it's a 1 by R is equals to 1 by R1. I'm talking about the R equivalent, 1 by R1 plus 1 by R2. Yes, so 1 by R can be written as 1 by R, which is equals to P by V square. So that can be written as that P equivalent divided by V square is equals to P1 by V square plus P2 by V square. This V square can be gone, and this P equivalent can be written as P1 plus P2. I hope these things are clear. Is it clear? So when bulbs are connected in series, their relation would be just like in parallel, and when bulbs are connected in parallel, their power consumption would be just like they are connected in series. I hope those things are clear. So have you noted this? Great. Let's look at the questions based on the same data. The data given is something like this, that this is the first bulb, this is the second bulb, and they have been connected with certain supply. The rating of this bulb, it's a 60 volt 220 volt. This is of 100 volt and this is of 220 volt, and they have been connected with a supply of 220 volt. So as you can see this, that this supply voltage and their individual voltage rating are the same. So the question is, find total power consumed by the circuit shown. So now what I know is that 1 by P equivalent can be written as 1 by P1 plus 1 by P2, and this 1 by P equivalent is equals to 1 by P1 plus 1 by V2. Let's put up the value. It's a 1 by 60 plus 1 by 100. Let's just try to get it done. It's an 100 plus 60 divided by 100 into 60. So this is 160 divided by 100 into 60. This is 1 by P. What I want an P equivalent. So that should be is equals to 100 multiplied by 60 divided by 160. This 0 has gone. This is 3, this is 8. So this is 300 by 8, which could be written as 150 by 4, could be written as 75 by 2, could be written as 37.5 watt. I hope this is your answer too. Is it? Is it same? Great. Ready for one more question? Are you? Let's have a look. Suppose the situation is something like this, that this is the bulb and these three bulbs are there. which have been connected with the supply. The supply is V. This is of 60 volt. V would be the rating. This is of 100 volt. V would be the rating. And this is of 40 volt. V would be the rating. So again the same question. Find out total power consumption of the shown circuit diagram. So how can you do this? What I understand is these three are connected in series, and when they are connected in series, I can have this. It's a P equivalent should be equals to P1 plus P2 plus P3. So this P1 which is equals to 40, this P2 it is of 60, and this P3 that is of 100. So this 40 plus 60 it's an 100, and 100 plus 100 which is equals to 200 volt. This is the total power consumption of this circuit. This is the total power consumption of this circuit. Is it clear? Is it? So I hope you can do this kind of normal series parallel kind of questions. So let's have a look to the new pattern of question based on the bulbs. Let's have a look. This is the first circuit, second bulb, and the third bulb. And let's suppose this is connected with the supply. Now this is connected with battery V. This is, let's say, bulb of 60 volt, and V would be the supply. This is of 40 volt, and V would be the supply, and this is of 100 watt, and V would be the supply. So let's suppose what I need to find out is what would be the which bulb will be having the higher power consumption. So how could I find it out? How could I find it out that which bulb is consuming the higher amount of power? Find out power consumption of each bulb. So how could I calculate it? How could I calculate it? So as I can see, each one is having the same voltage. Each one is having the same voltage, but their power consumptions are different. So if each one is having the same voltage but their power consumptions are different, so definitely 100 volt bulb will be consuming more power. And 60 and 40 would be next to them. So power of 100 will be greater than power of 60 volt, will be greater than power of 40 volt. I hope these things are clear. Is it clear? Is it clear? Great. Ready for the next question? Are you? Let's have a look. Suppose a one bulb is given and it has been attached with the certain circuit. The rating of this, it's let's say 200 watt, and this is of 100 volt, and this has been connected with, let's suppose, 80 volt. Let's suppose something like this. Now what I need to find out, find current is passing through this circuit. You need to find out the current that is passing through this circuit. So how can you do this? So what you need to do understood is that this bulb can behave as a resistor, and you can calculate the resistance of the same. How? Let's have a look. It's a P is equals to V square by R, and from here you can have this, that R resistance is equals to V square by power. This R can be written as this V square. It is not an 80 volt, this is of 100 volt, because this is the voltage rating of the bulb. So if I write it's an 100 into 100 divide by its power rating, which is of 200. So this 2 has gone, and this is of 100 ohm, this is of 2, it's a 100 by 2, which is of 50 ohm. This is the resistance of the bulb. I hope this is clear. Now current that is passing through the circuit, that is equals to I is equals to V divided by R. This is the supply voltage, and my supply voltage is of 80, resistance it is of 50, and this is the current. This is 80 by 50, 8 by 5, which is of 1.6 ampere. This is the current that has been passed through the circuit. Yes, I hope this is clear. Is it clear? Is it clear? Great. So ready for the next question? Let's have a look. What does it says? It says that an immersion heater is rated 836 volt. It should hit 1 liter of water from 20 degrees Celsius to 40 degrees Celsius in about. Yes, very good question. That this is the multiple concept questions. Yes, a immersion heater is given whose power is given, it's a 836 volt. So I can write like this, it's a power is equals to energy divided by time. Yes. Now the question is, how could I do this? It's a 1 liter of water from 20 degrees Celsius to 40 degrees Celsius. If you have remembered the thermal properties of matter in class 11, and you were doing the calorimetry, that calorimetry says that the certain amount of energy is required. It's a Q is equals to MC delta T. Yes, let's say it's a 1 liter of water, approximately 1 kg of water, or in reality it is 960 gram of water, but let's assume this as a 1 multiplied by C. It's a specific capacity of water. What is it? It's a 4186. Yes, I am taking this in an SI unit, and this is equals to delta T. This is 20 degrees Celsius, that if this is 40 degrees Celsius, so this is 20. So this is 4186 multiplied by 20. This much amount of joule is required. Now what you need to do is, it's a power that is equals to watt per time, or this is equals to power that is equals to energy by time. Yes, that is the Q by time. Power is given, that is of 836. Energy required, that has been mentioned, it's a 4186 multiplied by 20. Time is to be find it out. So this is 4186 multiplied by 20 divided by 836. Please get it done and find out the answer. Yes, I understand that it takes a certain amount of time to get it done or to solve it, but what I want is, do you understand this? Do you understand this? Yes, this is the multiple conceptual questions. Yes, it takes a certain concepts from class 11, certain concepts from class 12, and the things seems to be difficult. Yes, let's have one more question. What does it says? It says a 5 degree Celsius rise in the temperature is observed in a conductor by passing a current. When the current is double, the rise in temperature will be nearly, okay, how could I do this? What it says, when the current is double. So let's have a look that what they are supposed to talking about, that heating effect of electric current that depends on the I square, it depends on the resistance, it depends on the time for which it is flowing. Yes, so if if they are supposed to, change the current, because they says the current is double, so they are just changing the I parameter and keeping the R and T as a constant. Same way, can I write like this? It's an Q or H is the energy which is equals to M into C into delta theta. So they just want to focus on the delta theta, so I can write like this. It's an H that is directly proportional to the delta theta. So now what I understood is that delta theta is directly proportional to the I square. So it's a delta theta 1 divided by delta theta 2, that is equals to I1 square divided by I2 square. Delta theta 1, it's a 5-degree rise. Delta theta 2, that I need to calculate. I1, let's assume it as an I. I2, it's a double, it's a 2I whole square. This is I square. So this is I square has gone and 1 by 4 has remained. So delta theta 2 could be written as 5 multiplied by 4, which is of 20 degrees Celsius rise. This would be the answer. What was your answer? Is it same? Is it same? Great. Well done. Ready for the next question? Ready? Let's have a look then. What data is saying? According to the data, a 60-volt bulb carries a current of 0.5 ampere. And what do you need to find out? You need to find out total charge passing through it in 1 hour. Okay, great. So I know this, it's an I which is equals to Q by T, and from this Q can be written as I into T. The current that passes, it's 0.5 ampere. I can write like this, it's a 1 by 2 ampere, and time is 1 hour. 1 hour, that means a 60 minutes multiplied by 60 seconds. So this is 2 into 30 and 30 into 60, it's a 1800 coulomb. That's it, you did it. Great job. Yes, this is a question of less than 20 seconds. Yes, but you must calculate this. Yes, your mind must strike it that I can get it done in this manner, that I equals to can be written as Q by T, and then Q can be written as I into T. Is it clear? Is it? Great. Ready for the next question? Do it quickly. You are doing good. Let's have a look to the next question. What is saying? It's a heater coil is cut into 2 parts of equal length and only one of them is used in the heater. Okay. The ratio of the heat produced by this half coil to that by the original coil is. So how could I do this? So initially, what was the situation? Let's suppose this is the heater coil. I can consider it as a resistance. Now it has been divided into 2 parts. So each part must be having a resistance of R by 2, and one more, again it's a resistance of R by 2. Now the ratio of the heat produced by this half coil to that by the original coil. What I can understand is that H can be written as V square by R multiplied by T, because here, if here I am supposed to write I square RT, I need to even the change in current as well. Yes, because as resistance is increased, initially it was R, now it is R by 2, so its resistance is decreased, current should be changed, and I need to calculate it. So to remove this ambiguity, I am not using this. I hope these things are clear. Now what is changing? It's an R which is changing, so I can write like this, it's an H inversely proportional to the R. So let's have a look at that. It's an H1 by H2, which could be written as R2 by R1. H1 is the initial situation, it's a, let's say H. H2 is the new situation, let's say H2. R2, it is the half of the resistance, which is R by 2, and initial resistance, it's an R. So this H1 by H2, it is a 1:2. They have asked the heat produced by this half coil to the original coil, so they have asked H2 by H1, and that can be written as 2:1. This is the answer. What was your answer? But do not make a mistake to use this. Why could you don't use it? Because here the resistance changes, and when resistance changes, I will change as well. So that's why I cannot use this, or I need to change this both. I need to change this both. If I could change this both, you can use it absolutely, but this would be the faster approach. This would be the faster approach. Is it clear? Is it? Are you sure? Ready for the next question? Let's have a look then. The data is two electric bulbs whose resistances are in the ratio of the 1:2 are connected in parallel to a constant voltage source. The powers dissipated in them have the ratio of, now in which they are connected in parallel to a constant voltage source. So the situation would be something like this. This is the first bulb, this would be the second bulb, and let's assume that this is having resistance 1, this is having resistance 2, and they have been connected with the supply. Now as they are connected in parallel, what I can have is P is equals to V square by R. But as they are connected in parallel, their voltages would be equals. So what I can write, it's a P1 by P2, that is the V has been gone, it's a 1 by R1 and 1 by R2. So let's suppose that this is 1 and this is of 2R. Yes, because they are having a resistance of 1:2. So let's put up the value. R2 will be equals to 2R, R1 will be equals to R, and this 2 has been cancelled, and this will be 2:1. And the numerical has been done. Is it clear? Is it? Are you sure? Yes. Next question. What it is saying? It says three equal resistors connected in series across a source of EMF together dissipated 10-watt power. Three equal resistors connected in series. This are connected in series. The power dissipated if the same resistors are connected in parallel. Very good question. Now when first when they are connected in series, first case it's connected in series. When they are connected in series, their equivalent can be written as 1 by P equivalent. That could be equals to 1 by P1 plus 1 by P2 plus 1 by P3. Yes, this are the equal resistance, so their power must be equal. So this can be written as 3 by P, but this is 1 by P equivalent. So if I write P equivalent, that could be written as P by 3. Now when they are connected in parallel, their P equivalent can be written as P1 plus P2 plus P3, and this all having the same power consumption, so that can be written as 3P. This is P equivalent of parallel, this is P equivalent of series. Let's have a ratio. So this can be written as P equivalent of parallel divided by P equivalent of series, could be written as this is 3P divided by P by 3, which could be written as 9 times. This 2 would be a gone. So it's a P equivalent of parallel is equals to 9 times of P equivalent of series, and the P equivalent of series is given, it's a 10 watt. So this could be written as 9 into 10, which could be written as 90 watt. I hope this is clear. Is it? Now one more thing that you must remember this. You must remember this relation, that P equivalent in parallel to the P equivalent in series would be always equals to n square. Yes, here n is the number of power dissipating components. Here n is the number of power dissipating components. Yes, yes, you can use it if power consumption of all components are same. You can always use it. This is P equivalent in parallel to the P equivalent in series would be equals to n square, and n is the number of power dissipating components. This is very important. Please remember this. This will help us. Is it clear? Is it? Great. So ready for the next question? Yes, this is very logical and very beautiful question. Let's have a look. What does it say? It says a 25 volt and 220 volt bulb and 100 watt and 220 volt bulb are connected in series across a 440 volt line. So what would be the situation that any one of the bulb will fuse, that is the only 100 watt bulb will fuse, or only 25 volt bulb will fuse, or both are working, or both will fuse? So how could I do this? So let's just check it out, that how this can be done. Then let's suppose this is first bulb, this is the second bulb, and they have been connected with the supply, and with the supply is of 440 volt. This bulb is of 25 watt and 220 volt. Even this bulb is of 100 watt and 220 volt. Yes, this is the situation. So what I can do is that let's just find out the maximum current handling capability of each bulb, and then just calculate the current that is actually passing through the circuit. But how could I do this? So what I understood is that P is equals to V square by R. It is the correct relation. Yes, so I can use this, that R is equals to V square by P. Using this I can calculate the resistance of each bulb. Let's suppose that R1, this is the first bulb, this is the second bulb. R1, it is equals to V square by P. This V square, which is equals to 220 multiplied by 220 divided by 25. Same way, R2, it is equals to 220 multiplied by 220 divided by 100. This is the in ohms. Yes, this is the resistance of each bulb. Now what you need to do is you need to find out the current that can be passed through it. How could I calculate it? Let's have a look. That I max or I1 max could be written as V1 divided by R. My V1 it is of 220, and my resistance it is of 220 multiplied by 220 multiplied by 25. This 2 has gone and the term remain, that is of 25 divided by 220 ampere. This is the I1. What is I2? It's an I2 max, that could be written as V2 divided by R, and V2 it's an again 220, and the resistance is 220 multiplied by 220 multiplied by 100. This has gone, this is gone, and this is equals to 100 by 220 ampere. I hope these things are clear. This is the maximum current that can pass through this. So if I now calculate the current that passes through circuit, it can be written as I is equals to V divided by R1 plus R2. So this V is the 440 volt divided by resistance. The first resistance, it's a 220 divided by 25. 220 into 220 divided by 25. plus this is of 220 into 220 divide of 100. So this could be written as 440 divide by 220 square into 1 by 25 plus 1 by 100. So this could be written as 4 by 100. I'm going to multiply this on both the sides, so that can be written as 4 by 100. This could be written as 440 divide by 220. So this is 440 into 220 into 220. This can be cancelled by 2 into 4 by 100 plus 1 by 100. This is 5 by 100. So this is 5 over here and 100 over here. So the term that remain, this is 5, this is 20. So this could be written as that I is equals to here 20 over there, here 2 would be there. This is equals to 20 by 2 equals to 40 divide by 220 ampere. This is the current that has been passing through the circuit. So let's just check it out. What was my I1 max and what was I2 max? My I1 max was the 25 by 220 ampere. I2 max was the 100 by 220 ampere. So let's have a look. This is the current that has been passing through the circuit. This is the current that can be maximum passed through the bulb 1. This is the current that can be passed through second bulb. As value of an I which is greater than I1 max, so it will fuse first bulb and second bulb will be safe. Is it clear? Is it clear? As I is greater than I1 max and I is less than I2 max. So as I is greater than I1 max, I can say that first bulb will be fused while this second bulb can start operating. I hope these things are clear. Is it clear? Is it? So do you understand it fully, that what could be done and what could not to be done? Yes. Ready for the next question? This was very interesting question, very interesting question. Yes, please remember methodology and the concept behind this. Please do remember this. Next, let's look at this question. Easier one. What does it say? It says that two electric bulbs whose resistance are in the ratio of 1:2 are connected in series to a constant voltage source, and you need to find out the power dissipated in them. Yes, they are connected in series. Look at this. So when they are connected in series, the situation would be something like this. Yes, and they have been connected with the certain voltage source. As I know they are connected in series, P is directly proportional to the R, because P is equals to I square R, and as current will be the same, P is directly proportional to the resistance. So when they are directly proportional to the resistance, what I can have? It's a P1 by P2. That could be written as R1 is to R2, and R1 is to R2 it is given as 1:2. So their power consumption would be equals to the same. It's a P1 is to P2, could be written as a 1/2. Is it clear? Is it clear? Great. So ready for the next question? Ready? You are doing good. Keep it going. Let's have a look to the next question. Do it fast. What the question is saying? It says two identical heaters, a 220 volt and 1000 volt, are placed in series with each other across 220 volt line. Then the combined power is, yes, they are placed in the series. That is what it is saying. So when this devices, when the devices are connected in series, the equivalent could be written as P by N, because this is the relation 1 by P equivalent is equals to 1 by P1 plus 1 by P1. This could be equals to 2 by P1, and so P equivalent could be P by 2. It is the same thing, it's a P by 2. Their power, it's 1000 watt each, so this is 1000 by 2, and the total power consumption is 500 watt. Is it clear? Is it? So shall I add something to this question? Let's have a look. In the previous question, if heaters are connected in parallel, what should be the power consumption? What should be the power consumption of combination? So here they are connected in parallel. Here they are connected in parallel, and if they are connected in parallel, so P equivalent can be written as P1 plus P2, and each one is having a power of 1000 watt, so that can be written as 1000 plus 1000, that would be 2000 watt. This is the P equivalent. I hope these things are clear. Is it? Is it clear? Is it? Great. Ready for the next question? Are you ready, guys? Are you sure? Can we do it? Let's have a look. What does it say? It says that three equal resistors are connected in series. Yes, this is the same question that we have already discussed. Yes. Next question. Let's look at this. It says that two electric lamps of 40 watt each are connected in parallel across the main supply. The total power consumed by the two bulbs together, it's an P equivalent, that could be written as P1 plus P2, and this is of 40, this is of 40, total would be of 80. This is the P equivalent. That's it. You did it. Yes. Next question. A 25 watt 220 volt and a 100 watt 220 volt bulbs are connected in parallel. Look at this. This is the difference. Initially in the previous question what we did, they were connected in series. Now they are connected in parallel across a 440 volt line. So what should be done? So how could I do this? How could I do this? Let's first have a rough sketch of the situation. This is the first bulb, this is the second bulb, and this both are connected. This both are connected with one another supply. The rating of first bulb, it's a 25, 220 volt. The rating of second, it's an 100, 220 volt. And I have connected this with the supply line of 440 volt. So in parallel voltage will remain the same. So when and when we used to have P versus V rating of any bulb, this V is the V max that any bulb can have. This is the maximum voltage that any bulb can have. If we are providing anything greater than V max, if we supply, or what, if voltage across any bulb is greater than Vmax, then that bulb will fuse. Here in this case, what you are supposed to do, you are providing a 440 to 220 volt. Here you are providing a 440 to 220 volt. So as 440 is greater than 220, both the bulbs will fuse. Both the bulbs will fuse. If they were connected in series, maybe one of the bulbs can be saved. But as they are connected in parallel, here both the bulbs will fuse. So let's have a look to the next question. If current in an electric bulb drops by 1%, then the power decreased by, yes, current has been dropped by 1% and you required in power. You have a relation, that is P is equals to I square R. So from this you can have, it's a delta P by P could be written as 2 into delta I by I. Yes, as whatever the change is less than 5%, change is less than 5%. So when change is less than 5%, you can use the relations that has been given or that has been provided for the errors. So this could be written as 2 into 1% and this would be the 2%. That's it. You did it. Great job. Ready for the next question? Are you ready? Let's have a look. What question is saying? The question is that an electric bulb is rated by 220 volt and 100 volt. Power consumed by it when it is operated on 110 volt. Yes, very interesting. The situation is something like this. This has been connected by 110 volt. This is of 220 volt and 100 watt. So what you need to do is first calculate the resistance of this. It is a P is equals to V square by R and R would be equals to V square by P. So this is V square, which could be written as 220 multiplied by 220 divided by power, it's in 100. Yes, so this many ohms would be the resistance. Now let's just calculate the current through the circuit. I'm talking about this current. This IS could be written as V by R and this V would be 110 divided by its resistance. It's a 220 into 220 multiplied by 100. Yes, you understand this. It's 110 twos and this is 50. So this is 50 by 220 ampere. That is the amount of current that has been passed. Now what you need to do is you need to find out the power. So power consumption by bulb, it's a P is equals to I square R. The current, it's a 50 by 220. So this is 50 by 220 multiplied by 50 by 220 multiplied by resistance. The resistance is 220 into 220 divided by 100. So this is 220 into 220 divided by 100. So this has gone. And this is 50 twos and this is 25 watt is the final answer. Yes. What was your answer? What was your answer? So do you understand the physical significance of this? Do you understand the physical significance of this? Let's understood it according to the practical situation, that this bulb is of 220 volt and 100 watt. That means this bulb required a 220 volt if you want a brightness of or the lumens of 100 watt. But here what you are supposed to do is you are providing a 110 volt, which is less than 220 volt. So does this bulb will fuse? We say no, it is not, because you are providing a voltage which is less than its requirement. So it is not going to fuse. But does it give the maximum amount of light energy that it is capable of? No, it is not. Why? Because you are providing a lesser voltage. So this bulb is made up to produce an energy of, to produce a power of 100 watt. If you are connecting this with the lesser amount of source, it can provide only a power lesser than this. I hope this is clear. So does it fuse? We say no. Does it work? We say yes. With full intensity? We say no. I hope these things are clear. Is it clear? Any doubts in this? Anything? Any doubts in this? No? Great. Ready for the next? Let's have this. The question is that 3 electric bulbs 40, 60 and 100 watt have tungsten wire of the same diameter. Then the longer wire is used by, okay, 3 bulbs are there, 3 bulbs are there, and we understood that this is P is equals to V square by R. Even we understood that R, so their voltages must be the same. That means the power would be inversely proportional to the resistance, and resistance is directly proportional to the length. Yes, so power would be the inversely proportional to the length. So as soon as length is increasing, power is decreasing, and that means if length is decreasing, power will be increasing. Now I hope you can reach to the answer very easily. Yes, yes, great. Ready for the next question? We are on a verge of ending this session. Only few questions are there, so please have patience and let's work for the next question. A question is, a constant voltage is applied between the ends of a wire. The heat developed is doubled if, okay, great. So your voltages are constant that they have provided, and now they want to double the heat. How could we? So what I understand is that H is equals to I square RT, and I can write like this, it's a V square by R multiplied by R into T. Because voltage is constant, I can go through this, it's a V square by R square, sorry. So this is V square by R into T. Yes, now you understand that resistance can be written as rho into L by A. Yes, so if I solve this, I can have that it is directly proportional to the area and inversely proportional to the length. So now what you can do is that this is the possibility, area divided by length. Now what they have said that both length and radius are halved, both length and radius are double, only the radius is double or only the length is double. So let's have a check. That area is given, so I can write like this, it's a R square by L. So if I'm going to opt with the first question, both length and radius are halved, so thus W dash would be equals to R square by 4, and this is equals to L by 2. So this is the situation, this would be the R square by L by 2. This is the half of the power, so this will not work for me. A second option, both length and radius are double, that is W dash is 4R square divided by 2L. So this is equals to 2 into R square by L. Yes, this will work because this will double the power. So this would be the situation. Yes, by chance this has happened that I have just met my answer on the second option. If not, you should go through all these options. You should go through all this option and try to get it done. Is it clear? Is it? Great. Let's move towards the last question of this session. Let's have a look. What does it say is, It says that a bulb rated by 60 volt and 220 volt is connected across a 110 volt mains line. The power consumed is that this is the situation, this is the supply, and this has been connected with the supply of 110 volt. This bulb is of 60 volt and 220 volt. So what you need to do is you need to first calculate the resistance, which could be given as V square by P. So let's just try to solve this. It's a 220 multiplied by 220 divided by power, which is of 60. Calculate the current that has been passing through the circuit. So this is 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 equals to supply voltage divided by resistance of the bulb. Supply voltage it is of 110. The resistance of bulb it's a 220 multiplied by 220 divided by 60. So it would be something like this. This is 2, then this is 30. So the current that is passing through the circuit it's a 30 divided by 220 ampere. This is the current that has been passing, and I can have this, it's a P is equals to IS square multiplied by resistance of the bulb. The current it's a 30 by 220 multiplied by 30 by 220 multiplied by resistance. The resistance is 220 into 220 divided by 60. This has gone. This is 32s are 60 and this is of 15 watt. What was your answer? Is it same? Is it? Great, you did a good work. Yes, so let's just wind up the session over here. This is all about the electrical energy and power. Yes, we have covered many other applications in the single session, but this is not all. The remaining questions we are going to conduct in the PCQ sections. They are the previous year asked question sessions. Yes, but at least practice all this type of question. This will help us and practice will save us. Thank you. Have a good day. Take care.